Okay, let's now continue here. The magnets in motion. Oh, let's repeat it. As I said, as you see in the videos here, we said that the shape of the magnetic field, as you see, they are try to see how the magnetic fields will be. They told us that they make lines from the north to south. These lines are not imaginary, they are real, but we cannot see it by our eyes. The two things that, how did they know how the strength of them and how the direction? By the strength of them, they used the iron filings in order to see how the strength of each magnet, and the compass in order to see how the direction of the lines will be, how they will be from the north to the south. Now, let's see what is the why we have a magnetism. Inside the magnets, the magnets is made from material, and this material, it contains an atom, and inside the atoms we have an electrons, and each electron, it has a positive and negative. So inside the atoms here, we have as we said, we have a charge, positive and negative. These charges now, when they arrange, they make two poles. One is south and one is north. Now, the area where the atoms are connected to each other, we call it domain. Some of them, here we have an north and south. This is the first atom. The second one, we have south and north. So for each one, they have a tiny magnets. One have a south and one has a north. Now, the strength of the magnet depends on how these domains will be arranged. If they are randomly oriented, there's no magnetic force. And if they are arranged in lines, we have a magnetic force. As you see here, they didn't arrange in lines like this. No, they arranged randomly. One's like this, one's like this, one's like this. So they are arranged randomly, especially in copper and aluminium. Go now, bring your spoon. Your spoon at your kitchen made from aluminium. Put the magnet beside it. You will see that they will not attract to it. Why? Because there's no south and because there's no electric charge? No, theirs will be. But because they are randomly oriented inside this material, that's why there's no magnet. But now bring it for your fridge or for anything that's made from iron. If you bring the magnet beside it, you will see that they will attract. Why? They have a north and south, but these domains or these tiny magnets are arranged in lines. Since they are arranged in lines, we have an magnetism. So remember, in iron, nickel, and cobalt, these three elements, we call them ferromagnetic elements. I will repeat what we call them: ferromagnetic elements, iron, nickel, and cobalt. Now, they have a magnetic field. They have make a strong magnetic field. But who didn't make a magnetic field? Like copper and aluminium. So copper and aluminium, there's no magnetic fields, but the iron, nickel, and cobalt, or we call them the ferromagnetic elements, they are lined up, they are arranged in lines, so we have a domain that make a strong magnetic field. So here, let's summarize that. All the magnets have two poles, north and south. And the magnets, they have forces, such as the electrical forces. such as the gravitational forces, such as any type of force. We have an magnetical forces. Like poles repel and opposite poles attract. The third thing, that the magnetics are surrounded by a magnetic field. Now, at the pole of the magnets, we have the greater amount of force. So the magnetic force is the greatest at each pole of the magnet. Now, what makes an object magnetic? What makes the iron magnetic and the aluminium no, as an example, or the wood no and the iron yes? Because of what? Because of the domains. What are the domains? They are groups of atoms. If the groups of atoms are arranged in line, we have a magnetic field, or we have a magnetic force. And if the groups of atoms are arranged randomly, there's no magnetic forces, such as this picture here. Here they have north and south in each nail. But the first one here, since the nail or the domain are arranged randomly, so there's no magnetic force. But for the second one here, it will be magnetic. Why? Because the domains or the group of atoms are arranged in lines. That's it.